This is the demo of the working of the solid state relay humidifier that we have created inside the incubator. This LCD shows the status of the humidifier now, which is off at the present. When the humidity rises from 81 to 87, then the humidity will automatically turn. Humidity controller will automatically control that solid state relay which is connected to the humidifier. The humidifier is adapted version of the mosquito coil net. Now it is on because the humidity level has crossed the threshold temperature, and now it is 87. That's why humidifier is on. This is a modified version of that mosquito repellent coil in which we have inserted water inside it, and that's why whenever it gets on, the water vaporizes from the charcoal end here and fills in the compartment. The compartment is now open to show you the working of that incubator. This one here is can be folded onto itself, and this one here goes right beneath it like this. Now the things are there, that's why it's not closing. This one here is the Arduino board, which has about 13 digital pins out and 7 analog pins. The two LM35 here shown is a recreation of a psychrometer, in which one is the wet bulb psychrometer and another is the dry bulb thermometer. Dry bulb thermometer shows the ambient temperature of the surrounding. Wet bulb shows a decreased temperature because it is immersed in water, or as in this case it is coated with as in this case is overed by a wick. So the difference between these two temperatures calculated with a psychrometric program here defines the humidity level, which is now temperature difference is 0.98. That means humidity is 87, and this connects the relay. Temperature difference, humidity is 81. That's why humidifier is off now. The working of the fan is still incomplete, and now I'll just connect the fan and then we'll see what happens. In this case the fan is connected to that Arduino board which has a digital pin out from here, and whenever the humidity level rises from around 100 relative humidity, then the fan works as an exhaust device, which we'll show you shortly. This is the calibration of the pulse oxygen meter. We are seeing here is the real-time display which is being connected to two IR modules. One is the IR TX, one is RX, and in between them is the space. And whenever we insert a blue foil or a white foil, then we see a change in the resistance, which is to the order of 10 to the power 3. The psychrometer setup, in which the first temperature module is connected with the first analog input and the second temperature module is connected to the one analog input from the Arduino, and we just find out the difference between both of them to find out the humidity in the air. And this is the code. This LCD gives us the information about humidifier status and the humidity and the temperature difference between the two LM35s. These two LM35s are differentiated in a way such that this one tells the wet bulb parameter and this one tells the dry bulb parameter. This whole setup has been opened so that the videography purpose has been served. This is the chassis fan that is still not connected, only to make sure that this humidifier here is connected to the solid state relay here, and it is on now because the humidity level is less. Now humidity is 81, humidifier is off, and now humidity level has gone down. That's why it is still going off and on. We have set the humidity level maximum to 81. That's why it is not responding to 81. This is the working of the pulse oxygen meter, in which it is now saying that the pulse oxygen meter level is normal, and because the humidity level is low, the fan is switched on now. This is the fan setup and the psychrometer setup, and this one here is a TSOP 182 IR receiver, which is connected to the Arduino. Here we see the wet temperature showing, and humidity fan is on, and oximeter showing normal status. This is the starting of the Portobator system. If we insert a blue colored ribbon inside the checking list of that IR sensor, which is the pulse sensor, we get variable. Variable means there is an error in the system, or the oxygen is less than the amount which has been set as the differential parameter. Now we see that oxygen meter will say normal because there is no blue color in that. And this one here is the humidifier setup, which is connected to the solid state relay here, which is a 12-volt solid state relay, which we drive using a adapter. And this is the triode which connects which controls the fan, 12-volt fan. These are the psychrometers which I have covered, and this is the whole setup. The LCD system is being connected to all the sensors, so that it shows all the exact all the statuses in one single screen. And now you can see or hear the sound of the relay being switched on. Again and again. It is due to the variable readings between the psychrometer, which has been served as a humidity sensor. The digital pin is connected with that LCD module of the Arduino. The Arduino here has an Atmega 328 processor, which can handle about 7 to 8 sensors and 13 digital out pins. This is the pulse oxygen meter, which contains one IR and one TSOP IR sensor. The TSOP IR sensor can modulate frequency between 38 MHz. These are the two LM35s. This is the 1400 mm SMPS fan. The whole setup once again folds into place. Because this is a replica which we have used a whiteboard to make it, and that's why the folding is not as we intended it to be, but in the original it will be like that.